review is great because it gets a little more fun, and things start to, you get familiar with them. I just got the first and now the second of 3 solo guitar parts for Pink Floyd's Wish You Were Here, and now I remember them. I didn't think it was possible. I didn't think it was possible. But I just, 10 minutes a day, literally 10 minutes a day for, I don't know how long it took me, weeks. Check this out. Let's see if I can show you this. Angles, right? So there it is, starting from the center here, and then making pizza slices. There's 10, 5, and 1 degree. I just wanted to review that real quickly because, as I said, angles are super critical, as I said yesterday, for astronomy. And reminding us that, and I did this, I knew it was off by like a degree, and I realized in watching the video that I put my eye like a little too much here. So anyway, I wasn't quite there, but I got it a little better. There it is. Maybe it should be a little bigger, but there's my fist at arm's length. And when I measured that, remember that we got that to be about, well, that's good now. I did it better, and that's 10 degrees. So 10 degrees there. That's how much around. And you could break up the full pizza into as many parts as you want. You could talk about a whole pizza, half a pizza, quarter pizza, but people decided on 360, and that's tied to the base 60 numbers, right? So we've got that, and we see that anybody, even if you've got a shorter arm, you'll have a smaller fist. A longer arm has a bigger fist, kind of like that. I'll show that to you real quickly, quick review. So it can't be here, right? If my fist is not at arm's length, it doesn't work. It's got to be at arm's length. And what am I looking at? Anything past my pinky, I'm looking at, and anything here. So this could be Moon and Mars. Moon and Mars, looking past that, right? Right now my thumb blocks, not quite. The phone is less than a thumb length at arm's length. It's about 1, 2, 3 pinkies. And what's a pinky? Well, a thumb is about half of if you do it, a thumb is about half of a fist. So 10 degrees is a fist at arm's length. 5 degrees is about the length from this side to that side. That would be the wedge going to your eye, right? Your eye makes you see something there, then you see something there, then those 2 stars or planets or moon and planet or whatever are 5 degrees apart. That's the apparent separation, also called the visual separation, but I call it the angular separation. Well, people call it the angular separation. I kind of like that name because we're talking about angle, right? And 5 degrees, and then your pinky tip width across there. So if you go like that from one side to the other, that little wedge makes about 1 degree. Maybe a little more, but about 1 degree. So depending on your fingers, those vary quite a bit. Okay, so the pinky, 1 degree is about a width of a pinky tip. Right. Notice that as these lines go out, they get farther and farther away. It's still 10 degrees though, right? So that's interesting. Now let's talk about that a little bit. And before I do that, let me just say, remember this: 1 degree then is a pinky width, pinky tip, I should say, width at arm's length. So what would that arc minute be? Right? Dividing a degree into 60 parts, just like we divide an hour into 60 parts. We divide a degree into 60 parts. That's called an arc minute. That would be 1/60th of that. So what you do to see that, get a really sharp knife, take your pinky and divide it into 60 pieces, and then pull 59 back, and that little sliver that's left there from one side to the other, that's an arc minute. It's a pretty small slice of pizza, right? And then you take that sliver and you divide it 60 more times. That's an arc second. Okay, that's it. Just kind of have a sense of those. So when we talk about getting great telescopes, we're talking about things that appear very, very close together, but the telescope will separate them, magnify that separation so that we can pick out details. Okay, so it's not too big of a, well, it is a big deal, but it's not a lot to remember. Okay, so fist, thumb, pinky width at arm's length, degree, arc minute, arc second. I wanted to point out a couple of things, and that is, so two objects, no matter how far away they are, those are both on the same line. And so if I can't see this, it still makes the same wedge. It's still 10 degrees. The separation is still 10. This could be AUs away, this could be light years away. That's still an angle, if they're on those lines, of 10 degrees visually. It's visually, they look like they could be 1 degree, they look like they're right next to each other. They look like they're right next to each other. Small angle between the two. So the angular separation doesn't tell the distance, right? We talked about that little review there, okay? So that's one thing. We also know that an object, when it's closer, looks bigger. Why is that? Because from side to side, the angle that it would make, I'll do this, might be a little clunky, would be much bigger when it's close, and as it gets farther away, it gets smaller and smaller. Until here, it would look, I would say it has an angular size of 10 degrees, and then of course you can see it's getting smaller. It's not getting smaller, it's appearing. So getting is different than appearing. It's appearing smaller and smaller. That's why things look smaller in the distance. That's it. Right? Just that. Now, I thought it was kind of interesting to play with some numbers, and I want to do that too. Two objects, if you go out for 1 light year, now you know you're not going to hit a star. Even in our galaxy, 1 light year, even though that's 63,000 AU, not exactly, but approximately 63,000. It's very roughly 1,500 times farther than Pluto, way out there, 1 light year. You still haven't hit the closest star besides the sun. Got to go 4.2. And that star you can only see from the southern hemisphere. But as you go out, of course, imagine if I go across campus, those two lines are going to separate. What if they go out for an AU? What if they go out for a light year? If you keep going out for a light year, it turns out, now you don't have to look at this. You don't have to look at this. But, there we go. If you want, I did a little calculation. Again, we'll ignore this unless you like math. But how far apart would they be? Well, we use something called radians. It's another measure of angle. Again, you don't need it. And 1 degree is about 1/60th of a radian. 1 radian is about 60 degrees. And then I do this little calculation that approximately, I use a little arc, the separation between the two is the angle times the distance, but the angle has to be in these radian things. Don't worry about it. So 1 degree, that's just this little 1 degree. What if they're just 1 degree apart visually? 1 pinky tip apart, one side to the other. If I go out for 1 light year, which is 6 trillion miles, those two would end up being 100 billion miles apart. That's crazy, right? That's just like crazy talk. So those lines do separate quite a bit. So they look 1 degree apart, and in reality, they're 100 billion miles apart, okay, etc. So you can play with the numbers. Right? That's probably too much. I do want to say one thing though. I do want to show you this, because we talked about eclipses just briefly. We did eclipses. How can moon block sun? Sun is how many times? See, repetition, you'll get it. Just that's all it takes. No, have the confidence And even if you don't totally believe it, tell yourself you're going to get it. This ball here is half as wide. I can get 2 across this way, 2 this way, 2 that way. We're going to do this a lot in this class. 2, 2, 2. This one's twice as wide as this. Sun, in reality, is approximately 400 times wider than Moon, but 400 times farther away than Moon. This is twice as wide. What happens if I make it twice as far away? Of course, this one, if they're the same distance, this one looks twice as wide. But if I go like this, elbow, hand, pretty much, I close one eye, this little guy blocks the big guy. Why? Check it out. I've marked it. This is half the distance of that. I take this guy, put it in here. Hey, look at that. Kind of funny. It fits. It's 10 degrees wide visually. And this guy, if I move it out twice as far, it's twice as wide. Visually the same angle, so they block each other. Try it. You could even do that with your fist and your thumb right here. Right? Your thumb is half as wide as your fist. When you put your thumb, close one eye, put your thumb at your elbow, put your fist out there, and I see my thumb going right across my fist. Whereas if I go like this, it's about half as long. Kind of cool, right? So, so now we're going to go into talking about angles a little bit, and you'll have that familiarity with it. I don't think that it's necessary to do calculations, but if you have a lab course, an astronomy lab course, then that's fun to play with that a little bit. But now you've got a sense. All the cool things I think we've got. Yeah, all right, angles up.